Welcome back to Mr. Schroeder's Honors Chemistry class. We are talking today about Chapter 1. Going to continue covering Section 2 with describing matter. We've talked about SI units and conversion factors already. Today we're going to talk about characteristics of matter, including physical properties and chemical properties. Couple quick definitions before we go on. Volume is the space that an object occupies. Write this down. Mass is the quantity of matter in an object, which means that what is matter? Matter is anything that has mass and volume. And tomorrow in class we'll talk about mass and volume and what matter is. See if you can come up with some ideas. Anything that we're measuring in this class, we're talking about matter. We're talking about measuring things that have mass. We do not measure weight in this class. Weight includes gravity. Objects that we use to measure mass are our balances. We have those in the back. They measure things out in grams in our class. This is a comparison. These are two astronauts. This guy in picture A is on Earth. He's got a mass of 88 kilograms, and the guy on the moon has the same mass. Their weight is different. Newtons is an SI force for weight. We think about pounds as being a weight. This is why somebody on the moon can jump 25 feet in the air, because they're used to having to carry more weight. Going back to physical properties now, matter, anything that has mass or takes up space. Physical properties are anything that we can figure out without actually changing the substance. If you remember, the physical change is any change that occurs, like if we boil something or we melt water or melt ice, turn it into water. That's a physical change. Something where we do not change the identity, it's still water. So physical properties are things that we can measure then without changing the substance. So things like texture. Is something soft? Is it smooth? Is it rough? That's examples of texture. State, is it a solid, liquid, or gas? A number, its melting point is 0 degrees Celsius for water. Boiling point of water is 100 degrees Celsius. Those are things that are physical properties, because I can measure the temperature by boiling the water with a thermometer in it. Chemical properties now are things that you can't tell unless you destroy it, or if you try to destroy it. So, in general, it's talking about how a material, how a chemical, will participate in the chemical reaction. Examples. If I want to know something reacts with oxygen, I have to react it with oxygen. Iron reacts with oxygen to form rust. It rusts. Gold does not react with oxygen. It doesn't rust. Good thing we make jewelry out of it. Flammability. How do you tell if something is flammable? You try to burn it. If it catches on fire, it may be flammable. If it doesn't, well, it's not flammable. Here's a quick little video to talk about the comparison of some other properties. Pay attention to some of these, things like malleability, some of these other things that might come up as terms you might need to know.
Is a physical property called malleability. The rusting of iron is a chemical change. Iron's reactivity with oxygen to form rust is a chemical property. The food coloring in this water is red. Color is a physical property. Adding bleach to the solution changes the chemical composition of the dye, and it is no longer red. The ability of bleach to make other substances colorless is a chemical property.
Okay, so that's just a quick overview of some other properties. Malleability being the ability to bend things. Density. We're going to talk more about density in class. It is the mass of the object divided by its volume. Units can normally be in grams per cubic centimeter, grams per milliliter. We calculate it as density is mass over volume, or D equals M over V. Make sure you have that written down. You will need to know it. And question for you, is density a chemical or physical property? And why do you think that? We're going to talk more about that one in class and see if you can figure out density. Some example problems we're going to try here. If you have density of something, what is the density of a material with a mass of 43.67 grams, which I'll put on the top. Remember, it's mass divided by volume. So 43.67 grams divided by a volume of 8.25 milliliters. So when I punch that into my calculator, I can quickly find what the density of the object is. 5.29 grams per milliliter. Density of this metal. A plastic block has the following measurements. So how do I find density of a plastic block? Well, we know volume is length times width times height. So for this block, the density, these are all in centimeters. So I'm going to take 8.1 times 3.2 times 5.6, and I get 145 centimeters cubed. See if you can figure out density here. Pause the video and try to find density on your own. Okay, if you are back with me, I'm going to figure out the density of this object, 92.44 divided by 145, and I get the density of 0.63 grams per centimeter cubed. And density of a substance should be the same no matter what size the sample is. Again, this is something that we're going to practice in class. Now, what's important or interesting to note is that the density, because it's always the same, I can actually use it to identify a substance. So here's some common densities of some different substances. You can see things like gases have very low densities. Things like gold have very high densities. But most solids are somewhere in this range. Some liquids are around here. We do have some solids that will be lower. The plastic we just measured was a 0.63. So that we'll have some solids, but somewhere in this range of between 0.5, 0.6, and up to about 19 is about as high as you usually see. And I want you to be thinking about this. Could you use density to find out if this crown is pure gold? Be thinking on that. We're going to talk about that in class. So, signing off. This is Mrs. Schroeder, and we'll see you in class.